Hey class, so let's move up the pipeline beyond just thinking of how objects include each other, and now think about the view volume that we have. So I'm going to talk about view volume testing. So the idea is really simple. We have this view volume we can calculate, which represents what we can actually see, right? In orthographic, it's square, and perspective, it comes out like a frustum. So we have the view volume, and we can test our geometry against the parameters of that volume to see whether it's visible or not. So test geometry against the view volume to determine visibility. Okay. So there's a lot of ways we can do this, but basically we can do this in any space. But for now, let's just work in world coordinates. So we calculate the volume coordinates in view space. So let's draw this out. Oops. So remember, I have my coordinate system over here somewhere, and we have our camera in 3D space. And then, we have our near clipping plane here, and I can, let's try that again. And I can turn this into a frustum, right, like that. There we go. And this is our view frustum. Yeah, that didn't work. One of these days I'll figure it out, but not today. Okay. So this is a view frustum, and this is actually, we can think about this as a series of 6 planes. So if we calculate these volume coordinates in space, we get these 8 points, right? We get all these, the near plane 4 points, and the far plane 4 points, but we actually get 6 planes. Now, by planes, I actually do mean planes, so I'm going to highlight this. So even though they're not drawn as planes here, we should envision that the planes, if this is the bottom of our frustum, remember it does actually go off in all directions forever. It's a real plane. So we have these 6 planes. Now, what we can do is we can also say, well, I'm going to give my plane a normal and a direction, right? Which they have. So I have this plane, and I choose an up direction, and I do that for all my planes. I make them all point inwards. Okay, we make them all point inwards. So if a point is on the inside of all 6 planes, all 6 of our planes, then it's inside the view volume, and we should render it, okay? In the view volume. So of course this can also be done in the camera coordinates, right? Once everything's transformed, or an NDC. And we're going to come back to this because it's not as simple as it might seem. It does require the geometry to be transformed. Right? And even in world space, we have to do some transforming for our geometry because they're in object space, and we convert it with however we draw it, into world space. So we have to do some kind of work. And then if a point is outside one plane, I should write neater. If it's outside one plane, then it's outside the view volume. We can call. Okay, so that's the idea. So this is a geometric approach to view volume testing. we set up the planes, we calculate the coordinates of our planes for our view volume, and we can do this whether we're in perspective or whether we're in orthographic or whatever you have. We can calculate the view frustum or the view volume, we turn it into planes, and then we can actually test our geometry, whether they're inside that plane, before we put it through the entire pipeline. So I'm actually going to stop here because I want the next video to be standalone. So we'll come right back and learn about how do we actually do this. How do we tell whether a point is on inside or outside of a plane?